Much of what we learn in an algebra class is devoted to the process of solving equations. Let's take some time to reflect on some of the things we might have seen before this class. In the equation in front of us here, I have what's called a linear equation, and it's a linear equation because it's involving polynomial expressions of degree 1 only. It's fairly straightforward to solve this for x, and effectively what we want to do is apply some operations to both sides of the equation that replace it with an equivalent equation. For example, I'm going to add 5 to both sides of the equation. On the left side, I'll cancel out that 5, and on the right-hand side, I'll end up with 14. I'm then going to do another operation that's going to result in an equivalent equation that's dividing both sides by 2, and I find my solution that x is equal to 7. So we could say here that the solution set to my original equation is the set containing just the number 7. Now notice each time I said that I replaced it with an equivalent equation. What do I mean by equivalent? Well, two equations are equivalent if their solution sets have not been changed, so if they have the same set of solutions. And apparently doing operations like adding both sides by 5 or dividing both sides by a non-zero number like 2 results in an equivalent equation in the sense that doing so doesn't change the solutions to that equation. Therefore, I can get the solutions from my original equation from this much simpler one where they're transparent. X is 7. That is the solution. Let's look at a quadratic equation. Here I have 2x squared minus 8x is equal to 2x. And it's called a quadratic equation because it involves polynomial of expressions of degree 2. It's not currently in standard form, so I'm going to combine these two terms involving x's, and I'm going to do that by subtracting 2x from both sides of the equation. And when I do that, I'll have minus 10x is equal to 0 on the right-hand side. This is an equivalent equation. The solution sets are the same between my first equation and my second one. Now I have 0 on the right-hand side, and that's a good sign that you should try to factor the left-hand side. In this case, I can take a 2x out of both terms, and I'll be left with x minus 5. That's equal to 0. And we're now going to take advantage of what's called the zero factor principle. And this says that if you're multiplying two numbers together, I'll call them a and b, and you get a product of 0, then it must be that either a or b itself is 0. And we're going to apply that to the two factors of my expression. It must be that 2 times x is equal to 0, or it must be that x minus 5 is equal to 0. Dividing both sides by 2 in the first equation gets me x is equal to 0, and adding 5 to both sides on the right gives me x equal to 5. In this case, the solution set to my original equation above is the set including 0 and 5. Let's look at another example of a quadratic equation. Here I have x minus 2, that quantity is being squared, minus 5 is 0. It's tempting to want to expand or FOIL this binomial out here and then write things in standard form again. And you may have success doing that, but I actually want to take advantage of the form that it's currently in. Because if I add 5 to both sides, what I see on the left-hand side is the square of x minus 2, and that number is equal to 5. I'm going to take advantage of what I would call the square root principle. Suppose I square a number, I'm going to call it a, and I get a number b. So a squared is equal to b. Then it must be that a is the square root of b. And by that I mean the positive square root. If we're talking about b being a positive number, then it's the positive square root of b. Or it's its opposite value, the negative of the square root of b. We write that briefly as a is equal to plus or minus the square root of b. In this example, the number that's being squared is this number in parentheses. It's the x minus 2. So this looks like x minus 2, that's my a, is equal to the square root of 5 or the opposite of the square root of 5, plus or minus square root of 5. If I add 2 to both sides, I can write this as 2 plus or minus the square root of 5. Now keep in mind, this is really two solutions to this equation. One of them is x is equal to 2 plus the square root of 5. That's one option of a value that will satisfy the equation above. If you use a calculator to estimate its value, you'll get about 4.236. On the other hand, x could be the 2 minus the square root of 5, and if you estimate its value, it turns out to be about negative 0.2 3/6. So these are the two values that satisfy the equation above. And generally speaking, for a quadratic equation, we would expect there to be two solutions because it's degree 2. Let's look at a couple more examples. Let's try to solve 4x squared plus 7x minus 2 is 0. Notice it's not in this nice form that we saw in the previous example. It's already in standard form. One option you might try for a trinomial like this with 3 terms is to try to factor it. And I'm going to take a shot here. And again, it's a little bit of trial and error, but I see that 4, and I'm going to try 4 times 1 to get me the 4 that appears with the x squared. And then I look over here at the 2, and it's either 2 and 1 or 1 and 2 if this is going to work. And a little bit of trial and error quickly shows that you probably want the 2 to get multiplied by the 4 and the 1 to get multiplied by the x here, because I'm going to need them to add or subtract together to get 7x. And this will be an 8x, and this will be a 1x. So I'm going to put minuses initially, but I'm going to need a lot of positive x's to get 7 here. So I think I'm going to need to make this one positive. And then I just mentally check, and you should do so too. 4x squared, 8x minus x minus 2 gives me the expression above. Now we use the factor principle. 4x minus 1 is 0, or x plus 2 is 0. If I solve the first equation, x is equal to 1/4, and the second one says x is equal to minus 2. Factoring is very hit and miss. We were lucky in this example to stumble upon the right combinations, and it could be that the numbers that require you to factor just are not nice numbers, and so in some examples you just need to fall back on the quadratic formula. Here I have 4x squared minus 7x plus 2 is 0. We're going to use the quadratic formula to solve this one. You can try to factor it, but you won't have much success, and I'll remind you the formula here for the quadratic formula. Ax squared plus bx plus c is 0. Here a is some non-zero coefficient. And the roots of this, the solutions to this are called our minus b plus or minus the square root of b squared minus 4ac over 2a. We're going to apply that in this example. So x is up top negative b. Well, b is minus 7, so it would be the opposite of minus 7. Plus or minus square of b. The minus sign goes away when I square negative 7. It'll be 49 minus 4 times a times c. So 4 times 4 times 2. And then 2 times 4. And then we're just going to simplify. And you can see here that the zeros of this quadratic just are not nice numbers. That's an indication that you weren't going to have any luck trying to factor this using whole number factors, coefficients for the factors. And that's just the way things happen to be sometimes.